everybody. Today we are discussing the next topic of the retrosynthetic analysis and heterocyclic compound, that is the one group CC disconnection. And one group CC disconnection can be subdivided into the two types, that is 1,1 CC disconnection and 1,2 CC disconnection. Today we are discussing the how to synthesis the alcoholic compound by the CC disconnection. So we have there are two disconnection for synthesizing the alcoholic compound, that is the 1,1 disconnection and 1,2 disconnection. We know that we have three different classes of the alcohol, that is primary alcohol, secondary alcohol and tertiary alcohol. So let us moving from tertiary alcohol. So always remember that we are going to synthesis the tertiary alcoholic compound by the 1,1 disconnection. See here in this example, it is given a tertiary alcohol. We have already discussed the guidelines of the retrosynthetic analysis. First one is the retrosynthetic analysis is actually it is the reverse process of the actual synthesis. And the second guideline is we have to disconnect always the heteroatom. And third guideline, we have to avoid the chemoselectivity and we have to always disconnect the most reactive group first. But if you are following that rule, the second rule, that is disconnection of the heteroatom. See here, we can see one of the functional group here, that is the alcohol, and there is a CO bond here. But according to this rule, we have to disconnect in the CO bond. But if you are disconnecting the CO bond, we will get a synthon as one of the tertiary carbocation and OH minus. So if you are developing the OH minus, we will get a reagent, maybe ROH or anything else. But the reaction, the better way to do this target molecule is disconnecting 1,1 disconnection of the CC bond. So, as we discussed earlier, the name 1,1 is coming from the functional group which is attached to the carbon atom is named as 1. And we are going to disconnect the group which are connected to that carbon atom. So that's why the name of the disconnection is 1,1. And here we are disconnecting the CC bond. So the name is 1,1 CC disconnection. So in this example, we can see that all the substituent of the carbon atom are R1, R2 and R3. So all of them are the CC bond. So that's why now we are going to disconnect in the CR3 bond. So we will get the synthon as R1CR2 plus OH, that is a carbocation, and R3 minus. These are the synthon. If you are developing this synthon carbocation, we will get a keton, and R3 minus we will get a Grignard reagent. See here, for the synthesis of a tertiary alcohol, the starting material must be a keton and a Grignard reagent. So this is the possibility. So we have to remember that if the target molecule is a tertiary alcohol, always a starting material is a keton and the other one is a Grignard reagent. And the R group of the Grignard reagent will depend upon the target molecule. Next we are moving into the synthesis. See here, the CH3Br is react to the Mg in the presence of dry ether. We will get a Grignard reagent. After that, Grignard reagent react with keton and water. We will get tertiary alcohol. Now, next is the synthesis of a branched side chain molecule. So here the speciality of the alcohol is that one of the substituent of the alcohol is branched. So how will you prepare this target molecule? So in this retrosynthetic analysis, we have to remember that if the target molecule is a tertiary alcohol, one of the starting material must be a ketone and the other one must be a Grignard reagent. So if you are disconnecting this molecule, we have two possibility. Either we have to follow A or we have to follow B. If we are following A, we will get the synthon as 8 and 3. So if you are developing the 8, we will get 3-methyl butane 2-ol as the starting material and CH3 MgBr as the Grignard reagent. But it is very difficult to do the reaction according to A. That's why if you are disconnecting the branched chain of the alcohol, we will get the synthon as like this, and we will get a ketone of 4 and Grignard reagent, that is a hydrocarbon. See the structure of the hydrocarbon. This is the actual path for the synthesis of the target molecule. So if our tertiary alcohol containing a branched side chain, we have to disconnect the branched hydrocarbon first. So that is the actual method. And this is the synthesis method of the above reaction. CH3 MgBr react with the diene and we will get the tertiary alcohol. Now we are moving into the synthesis of a unbranched side chain alcohol. So these are the example for the 1,1 disconnection. See here in this example also we have the 3 substituent for the carbon which is attached to the OH group. The two of them are the same and one is the different. So we have to disconnect in the long chain hydrocarbon first, and we will get a synthon like 11 and the other reagent as 5, synthon as 5. So which is equivalent to a Grignard reagent. The 11 is equivalent to the ketone. And similarly, if it follow B, we will get a Grignard reagent and ketone as the byproduct. So we have to always remember that if the target molecule is a tertiary alcohol, if you are doing 1,1 disconnection, CC disconnection, the starting material must be ketone and a Grignard reagent. Now we are moving into the synthesis. This is the synthesis for the above targeted molecule. That's a very simple method. Now we are moving into the synthesis of alcoholic compound by 1,2-CC disconnection. See here, the 1,2, the name 1,2 is coming from, here in this example, the OH group is connected to a one of the carbon atom. And we have to name that carbon atom as 1 and the next carbon atom as 2. So now we are going to disconnect the CR bond here. This is a CC bond and this bond is with respect to the hydroxyl group attached carbon atom, the position is 2. That's why this disconnection is named as 1,2, and now we are going to disconnect CC bond. That's why the name is 1,2-CC disconnection. So after disconnection, we will get the 2 synthon, that is R minus and an epoxide. So this is the synthesis. Epoxide react with RMGX, we will get the target molecule. So here we remember that if the molecule is a secondary alcohol and if you are following the 1,2-CC disconnection, our starting material always may be a epoxide and a Grignard reagent. Now we are moving into the second example. See here, this is also a secondary alcohol, and if you are disconnecting, we will get a pH minus and an epoxide, and we are developing, we will get an Grignard reagent and epoxide. This is the synthesis of the molecule. Hope you understood the concept. Thank you.